So today, we're going to talk about building a bouncer for your app. No, seriously, it's this super important tool you need when you're dealing with massive success to stop your app from, well, from being loved to death.
Okay, picture this. You've built something incredible. It's gone viral. Users are pouring in. This is the dream, right? But instead of celebrating, you're watching your servers catch fire. Everything's slowing down, crashing. What is happening? Look, it's what they call a good problem to have. But let's be real, it's still a huge problem. You've got way too many requests hitting you all at once. It doesn't matter if they're from real fans or some bad actor trying to cause trouble. The result is the same. Your whole system can go down. So what do? We've got to control the flow.
All right, let's dive into what this viral traffic jam really looks like. Because it's not just about a ton of requests. It's about the pure chaos that happens when that traffic is completely uncontrolled.
The highway analogy is perfect here. Imagine a 6-lane highway, and suddenly 1,000 cars try to merge into one lane at the same time. Total gridlock. That's your app. For your legit users, everything slows to a crawl. But even worse, that chaos is the perfect cover for a single bad actor to launch something like a denial of service attack and just shut the whole thing down.
So how do we fix this? How do we manage the crowd? Simple. We hire a bouncer. A really smart, super fast digital bouncer. And that, my friends, is exactly what rate limiting is. Basically, rate limiting is all about defense. You're just setting some ground rules, like, hey, you can make this many requests in this amount of time. The point isn't to lock people out. It's about making sure everyone gets fair access and the app stays fast and stable for the entire crowd.
And this is so key. The goal here is to embrace all that traffic, not be terrified of it. When you have a solid rate-limiting system in place, you can scale up with confidence. You know your backend is safe from the wild, unpredictable mess that is the internet.
Okay, so how does our bouncer actually decide who gets in and who has to wait? Well, it uses this really clever idea called the token bucket algorithm. Just imagine every single user has a little bucket. We're constantly dropping tokens into that bucket at a steady pace. Now, every time they want to make a request, they have to spend 1 token. Simple, right? But what if their bucket is empty? Well, they have to wait for the next token to drop in. It sounds so simple, but it's an unbelievably effective way to smooth out that traffic flow.
All right, to build this bouncer of ours, we need the right tools for the job. We're not just picking one thing. We're going to combine 3 really powerful pieces of tech to make a system that's both lightning fast and super tough. And check this out. The analogy just works so perfectly. Think about it. Our Node.js server, that's the club's front door, where all the requests are lining up. Redis, that's our bouncer's super fast memory. It knows instantly who's who and how many times they've tried to get in. And the Lewis script? Oh, the Lewis script is the best part. That's the bouncer's unbreakable set of rules. Simple, non-negotiable, and it always gets followed. Okay, the system is all set up. So now let's follow one single request on its journey. Let's see if it can get past our bouncer. Time to see this thing in action. So a request shows up at the front door, our Node.js server. But nope, it doesn't get in right away. It's stopped at the velvet rope. The server takes the request's ID, kind of like a guest name on a list, and hands it over to our bouncer, Redis, to run a check. And this is where the real magic is. It's a concept called atomicity. See, when you have thousands of requests hitting at the exact same millisecond, you can have a big problem called a race condition. It's like 2 people trying to get through a door at the same time. They both see an open spot, they both go for it, and then they both get stuck. In our world, 2 requests might see there's 1 token left. They both grab it, and now you've let too many people in. The Lewis script is our secret sauce here. It tells Redis, hey, when you check the token count and take a token away, do it as one single, uninterruptible move. Don't let anything else happen in between. It's what makes the whole thing foolproof.
So, in the end, it all comes down to a really simple decision for our bouncer. The Lewis script looks at the user's token bucket. Is there a token in there? Yes? Great. It takes the token, updates the count, and sends back a 1. That means you're in. Is the bucket empty? Then it just sends back a 0. That's it. Sorry, access denied. So what happens when you get that 0? When the bouncer says no? Well, the server doesn't just ghost you. It sends back a very specific, very important message, the HTTP status code 429. That's the universal code for too many requests. It's a polite way of telling the user's app, hey, just chill out for a second, slow down, and try again in a little bit.
Okay, so we've seen the how. We know how it works. But let's zoom out for a second and talk about the why. Why is this particular setup, this architecture, So powerful for building real, modern apps that can actually scale.
Let's run through the wins here. First, that atomicity we talked about. Thanks to our Lewis script, the rules are ironclad. No one slips through the cracks. Second, scalability. You can spin up tons of copies of your app and they all talk to the same central bouncer, Redis. It just works. Third, protection. This is the whole point, right? Your important backend services are safe and sound, shielded from those crazy traffic spikes. And last but not least, efficiency. Redis is in memory, which means it is ridiculously fast. This whole check happens in a blink, microseconds, so your real users barely even notice it's there.
You know, what we've just walked through, it's not just some cool little piece of code. This is a fundamental pattern. It's a building block for any serious professional application. Honestly, understanding and implementing patterns like this is what separates a fun weekend project from a real, production-grade system that can actually handle success. So there you have it. You've built your bouncer. You've created a safe, stable environment where your app can really grow without breaking. The front door is secure. So, the only question now is, what amazing things are you going to build behind it?